Yes, good morning. Welcome to the next session of Rehabilitation and Retrofitting of Structures course. So, in the module 1, we have completed the causes and the damages due to earthquake. Next, let us get into the next module, that is influence on serviceability and durability, module number 3. Okay. So, before getting into this, let us understand these terminologies. Okay, these terminologies. Is it clear? So, because we have already defined what exactly is durability and what are the factors that is influencing durability. Now, let us know what is serviceability. See, in design of RC structural and elements course, you people have come across the limit state method of design of RC structural elements. In those, you people have read the two limit states, that is limit state of collapse and then limit state of serviceability. Okay. So, in this limit state of collapse, you people have designed flexural members, all those things, compressional members. Next, and also you might have done the design of structural element for limit state of serviceability. What is the meaning of serviceability? Serviceability means that refers to making a building which is functioning or useful. That is what service. That means it is giving a service. Okay, that is what the serviceability. So, in those serviceability or limit state of serviceability, two criteria will come in serviceability. Two parameters will come. One is main thing, that is cracking, and the next deflection, fire, overturning, sliding, settlement. So, these are all the various the conditions that will come across in the limit state of serviceability. So, I will start with today the limit state of serviceability in terms of cracking. Okay. So, in this mainly we are going to deal, in the module number 3, we are mainly going to deal with the cracking and some part of fire I am going to discuss, and then settlement. Okay. So, now coming to the cracking part. Okay. What I can say a crack, if I am going to relate with a human being, a crack is a cancer. I can say it is a crack is a cancer in the RC structural elements or concrete structures. I will repeat, a crack is a, what I can say, I can relate it to the cancer. It is just like a cancer in the reinforced concrete structures. Okay, you know that a crack, if it is a very minute thing, it is of a primary, okay, it is, I can cure or a doctor can cure it. If it is a major, the extent of cancer is more or much, then it may lead to the end of a life of a human being. Here also the same thing, if I can relate it to that's what I have been told in the first class itself, it is completely related to the human beings. Okay, this completely, the course is related to the human being. Okay, that means there human health monitoring, here structural health monitoring. Okay, so if I am going to take certain precautions in terms of crack, I can enhance the service life of a structure. If I am not going to take any precaution, then automatically it will finally lead into the collapse. So, that is why there is a proverb. The proverb is, prevention is better than cure. Prevention is better than cure. That is in the medical field. In terms of what I can say, coming to the course, prevention of crack is better than rehabilitation or repairing a crack at the end of a service life. So you need to prevent the cracks at earlier stages itself, or we need to arrest the cracks, or we need to avoid the cracks by proper construction methodology or construction practices. Is it clear? Okay. So now how I can define a cracking or a crack? A cracking is nothing but separation of a concrete into two or more parts. A crack is a separation of concrete into two or more parts. Okay, it will be divided into two or more parts due to fracture, or I can say failure. And this crack, what it does, it damages the artistic view of a building, it will damage the integrity of a wall. Okay, and finally, because you know that the crack will be, it will be active. I will discuss this part in the later module or later stages. You know that there will be cracks, some cracks will be active and some cracks will be inactive. The difference here is, inactive crack or a non-structural crack, what I can say, it will not run along the length or width. But an active crack, day by day, the width and length will keep on increase. That means what I am trying to say here is, it will give a lot of warning. The concrete structural element tried to give a lot of warning in terms of crack. So that you can enhance the lifespan or you can overcome the failure of a concrete structure. Is that clear? Okay, so with this brief introduction regarding the cracks, now let us get into the first causes or that influence on serviceability, that is effect due to temperature. Effect due to temperature. See, in the module number 1 or in the last session, we have been discussed or classified so many physical causes, chemical causes that are influencing or causing the deterioration of concrete structure. With those, okay, related, that is concrete deteriorate structure. Here also I am continuing with that same thing, some more parameters. We have been discussed so many physical causes, we have been discussed so many chemical causes. Okay, the next thing is, what will be the influence on serviceability or durability of concrete structural element due to the temperature? I will repeat. What will be the influence on serviceability and durability of concrete structural element due to temperature? If temperature affects on the concrete structural element, what will be the effect on the serviceability and durability? Is it clear? So let us get into this. See, this is a major issue in the concrete structure, that is effect of temperature, especially this cracking in massive concrete structures. Cracking in a massive concrete structures such as long span bridges, okay, flyovers, reactor plants, high-rise buildings. Okay, if you come across these, not only these type of structures and also coastal structures. Okay, coastal structures, long span bridges, flyovers, high-rise building. If you come across these type of structures, there the amount of concreting you are going to do, is massive. Okay, so in massive concreting structure, a key element you need to observe here is, okay, that is effect of temperature and a load. Effect, because it is a major issue nowadays. Okay, we need to give a more importance upon these two factors. Okay, we usually, our usual practice of a civil engineer or a design engineer, he will consider certain amount of loads, okay, and he will design the building, and he will give it to the execution. But not only the loads, but also the temperature variations. The temperature variation is a key factor, that is influencing on serviceability and durability of a concrete structure. We will discuss more upon this. Okay, so there will be two types of, I can say, the temperature changes that will be there in the concrete structural elements. The two type of what I can say effects or the temperature changes are, one is temperature changes internally. Temperature changes internally or differences, I can say, internally by heat of hydration. By heat of hydration. Next, temperature changes or differences externally by climatic conditions. This we have discussed in the module number 1. As I stated, the variation in the climatic condition in concrete structure has very much influence on serviceability and durability. I will discuss this part. Okay. Now, coming to the first one, that is temperature change internally by heat of hydration, or I can say internal temperature differences. Okay. So we know that in OPC, whatever the concrete we are going to produce using OPC, it will be exothermic reaction, because the hydration, whatever the hydration process that is going to happen, that will be exothermic in nature. That is, the heat will be liberated. So, coming to the large volume of concrete, that's what I've been told, that is massive concrete structure. This will be having a more effect on the massive concrete structures. So when you're going to pour a large amount of concrete, okay, a large volume of concrete placements, enormous heat will be liberated. Please note this point. Okay, if it is a massive concrete structure, enormous heat will be liberated, or the heat because of more heat of hydration. Okay, because of this, the temperature will also rise. Why? This temperature will be raised internally due to heat of hydration. Okay, because of exothermic reaction or because of liberation of heat, okay, the temperature also rises. This rise in temperature, okay, this will be what I can say, if I talk about in temperature, this will reach to a temperature of about 38 degrees centigrade. That means whatever the temperature rise that is going to happen after heat of hydration, it will exceed the temperature when you are going to pour the concrete or while the concrete has been poured. Okay, so there will be temperature variations. You just observe this. So whatever the concrete I am going to pour in the initial stages, okay, the temperature will be different. After hardening, that means this effect due to temperature will be majorly called, or the crack, okay, that is going to happen due to effect due to temperature will be happen after hardening of concrete. Okay, so the pouring temperature, a concrete pouring temperature will be different from hardening concrete temperature. As the day elapses, okay, because of heat of hydration internally, okay, then enormous heat of hydration or enormous heat will be liberated, or the temperature will be exceeded beyond the pouring temperature of a concrete. Okay. So this temperature variation will be not uniform. That is one more point. This temperature variation will not be uniform throughout the mass of a concrete. What I meant to say here is, okay, what have been mentioned now, that is 38 degrees centigrade temperature will not be constant in throughout the concrete or throughout the concrete structure. In some part 38, in some part it will be some more, okay, in some part it may be some lesser. So like that, the temperature variations will be there. Because of this temperature, okay, non-uniformity, it will develop a terminology called gradients. Temperature gradients will be developed. Okay, the temperature gradients will be developed. So this temperature gradient development will lead to a condition called internal restraint. Internal restraint. Okay, that means we are going to restrict the concrete internally. We are going to restrict the concrete internally. We are not allowing concrete to, okay, what I can say, expand, or we are not allowing the concrete to contract freely. We are restrict. That is what internal. We are going to internally restrain the concrete. Okay. So because of this temperature gradient development, it has led to internal restraint. Okay. So what is the meaning of internal restraint? Internal restraint means the outer portion of a concrete, okay, will start losing the heat, and the internal portion of a concrete will start gaining the heat. Okay, the outer portion of the concrete will start losing the heat, and the internal portion of the concrete will start gaining the heat. So this is the key, okay, point you need to underline. Okay, the exterior surface of a concrete is start losing the heat, and internal portion of a concrete will start, okay, gaining the heat. Because of these temperature differences, okay, so outer surface is losing and internal is gaining. Because of this temperature differences, okay, it will develop or it will lead to the tensile stresses. That tensile stresses is expressed as cracking. Thus, tensile stresses will be expressed as cracking or will lead to the cracking. Is it clear? Because of external or surface temperature will be different and internal temperature will be different. Because of these temperature differences, it will lead to the development of tensile stresses in concrete. So this development of tensile stresses in concrete will finally lead to the cracking. Is it clear? So this is regarding internal temperature variations. So that's why I want to highlight a very important point here. Okay, nowadays whatever the concrete practitioners or concrete technocrats, if they want to design a concrete mix for a particular condition or for a particular place, they also need to keep in mind regarding the temperature. Okay, by keeping a temperature as a factor, as a key element, you need to design a concrete mix. Okay, because next point, that is climatic conditions. Okay, there also I will be quoting some examples. Okay, how exactly the behavior will change in winter condition, summer condition, variations in climatic. Okay, but yearly the main internal changes, that means the temperature variation mainly, that will be happen mainly due to internal variations. Because of internal heat of hydration, that will be reflected as a tensile stresses on the exterior part, okay, as a concrete surface. You can see from the photo, okay, how exactly the internal restraint that has been happened, okay, from the photo you can clearly see, okay, the process, okay. And coming to the symptoms, that means how exactly you can visualize, the internal temperature differences, I can say internal restraint differences, okay. So the cracking resulting from internal restraint will be shown as, okay, what I can say, a shallow crack with isolated, a shallow crack, okay, it will be very, what I can say, a shallow one, okay, and it will be isolated, okay. And one more way, okay, I can see, and this crack will be propagated, throughout the length of the member, okay. So we need to, okay, take a precaution at this, okay, whatever the stages the crack has been initiated, and we need to proceed. This is the symptom you can observe. One is, okay, you can see the shallow cracks with isolated one, and another one is, okay, we can see that externally it will be running throughout the length of the member, okay. So how can we prevent this then? How can we prevent the internal and external variations? Okay, because I have been told that internally whatever the heat that will be generated or liberated, those internal temperature will be more than that of exterior temperature. Then only this particular crack will be caused. How can we prevent this? We can prevent this internal changes by using, very first one is low heat of hydration cement, okay. We can prevent by, number one, low heat of hydration cement. Low heat of hydration cement. So that is the first point we can go ahead. By using a low heat of hydration, we can prevent this thing. And also by using a supplementary cementitious material, that is blending a fly ash with a cement. There also you can arrest this temperature differences crack internally developed, okay. And the next point, we can do something like pre-cooling. Pre-cooling means whatever the constituents of concrete we are going to use, like water, aggregates, okay, these constituents we can cool it initially before using it in concrete, okay. We can, okay, reduce the temperature of water. That's what I have been told in the case of thermal movements. I have been discussed in module 1, that is pre-cooling of aggregates, okay, or use of cold water, okay. So depending upon the situation, if you reduce the temperature of water and aggregates, okay, we can arrest this internal temperature differences that is going to happen. That is called pre-cooling method. And one more thing we can do, post-cooling method. Post-cooling method means we are going to induce a pipeline inside the concrete structural element, okay, a pipeline, okay. This pipeline, through this pipeline we are going to supply the cold water or a water, okay, in order to reduce the temperature. Why? Because I have been told, okay, internally a concrete is gaining the heat, externally the heat is liberating. So if internally it is gaining heat means the temperature is increasing inside the concrete. In order to bring back the temperature or in order to reduce the temperature, if you are going to supply the water through the pipe, okay, then you can reduce the temperature. Or I can say you can match the temperature of a internal with the external. Okay, so this is the another method. Okay, and one more method is I can say using aggregates, or I can say having aggregates having lower thermal conductivity and modulus of elasticity. Okay, so aggregates having a lower thermal conductivity and lower modulus of elasticity, we can reduce this problem. And I forgot to mention, this internal temperature that is going to happen, that is internally gaining heat and externally liberating, these things will happen because the concrete is a low thermal conductivity material. Please note this point. Because of it is a low thermal conductivity material, this internal gaining heat, external liberating heat process is going to happen. So by these methods, we can prevent the internal changes, or we can say temperature differences that is going to happen internally by heat of hydration. Is it clear? Okay. We will move on to the next one, that is temperature changes externally by climatic conditions. So here also the basic mechanism of failure of concrete structural element, that is failure due to the tensile stresses development with the formation of cracks, Okay, same as that of internal temperature differences. Here also the same thing, the tensile stresses will be developed. But here the thing, the concrete element or concrete structures will be subjected to varying climatic conditions. Because of the concrete structural elements or structures that will be subjected to a varying climatic condition, tensile stresses will be developed. You can see from the photo. Okay, I've been you can see the external restraint condition. Okay, how exactly the internal restraint is happening, how exactly the external restraint condition is happening. See, for example, this will be this particular problem, mainly a concrete structure that will be exposed to the atmospheric condition. Mainly the concrete structure that will be exposed to the atmospheric condition is rigid pavements or concrete pavements. See, I am going to construct the rigid pavement or a concrete pavement during summer condition, or I can say in terms of March or April. Okay, later on this concrete temperature will be different during winter condition, or I can say rainy condition. That means during a March I have been constructed the concrete rigid pavement, okay, with certain temperature, maybe the temperature will be very high, I can say 30, 34 or 35, something like that. Okay, but when you come to the winter condition or raining condition, automatically the temperature will be reduced. It will be bring down to, I can say 24, 25, 23, something like that. If this temperature reduction is going to happen in the concrete structures, then automatically what will be the effect on the rigid pavements? If this temperature reduction or increase that is going to happen due to variations in the climatic condition, it will develop the tensile stresses. You can see or come across in the roads, or what I can say in the rigid pavements. That will be in terms of crazing. Okay, crazing, that is also one form of cracks, random crack. Okay, crazing is a one form of random, okay, pattern cracks that will be distributed. Okay, commonly you may observe these crazing cracks in roads. Okay, any structure that will be exposed to the sun condition. So that's why a concrete that will be exposed to during a sunlight, a concrete that will be exposed during winter, a concrete that will be exposed to the rainy, okay, the behavior will be different. So while designing, that's what, while designing a concrete mix, we need to keep all these parameters and need to design a concrete mix. So then only you can take care of these tensile stresses. That's what, okay, the temperature changes externally by climatic condition. Okay, here, okay, whatever the concrete, okay, I have been poured to a certain temperature, okay, that temperature may decrease or increase, okay, depending upon the climatic conditions. For example, if you are going to pour in the concrete in terms of a lesser temperature, or I can say in the November-December condition, if you are going to construct any concrete element or concrete structures, if that particular concrete structure, the behavior will be different when it comes on the march or during a march. Okay. So because of this climatic condition variation, it may develop a tensile stresses. So that tensile stresses will be reflected as cracks, will be reflected as surface cracks on the concrete structures. Is it clear? Okay. So how to and majorly, okay, I can say this particular cracks that is going to happen are visualized in what I can say as a expansion joints cracks, or I can say spalling, So that's why maybe you come across in the case of a flyovers, in the case of cement concrete roads, you may observe that they are going to cut down the concrete structural elements by giving a groove, Okay, so those particular groove is called as expansion joints. In the roads you might have observed, especially in the concrete roads or in the long span flyovers, okay, they are not going to cast the concrete continuously. Even though they are going to cast the concrete continuously, they are going to break the continuity of a concrete by giving a proper groove or expansion joint. Those expansion joint later they are going to fill with bitumen. Okay, by giving this, okay, we can prevent the climatic variation, okay, happening cracks or external temperature differences cracks. Is it clear? And also these external temperature differences will lead to the spalling. So spalling I have already been defined. Spalling means a chunk of a concrete will be separated or will come out from a concrete. Okay, so that is what spalling. It may be together with aggregate or only mortar. Okay, so it may depends upon the extent of what I can say. Okay, so by these things we can prevent this temperature effect. Okay, so this is regarding what I can say effect due to temperature or influence of temperature on serviceability and durability of concrete structures. And very important, I want to highlight here, sir, then you might ask, sir, what is the feasible temperature to pour the concrete? What is the feasible temperature, or what is the temperature a concrete should possess while pouring the concrete or while making the concrete? So the safest zone in terms of temperature I can say is between 10 degree to 30 degree I can say. So this is the safest temperature I can say. You can pour the concrete or you can go ahead with a construction practice. Okay, so this is regarding your effect due to temperature. Any doubts? Okay, so this completes the effect due to temperature. So next we will move on to the next thing, that is effect due to wear and erosion. Effect due to wear and erosion. Okay. So once if a wear or erosion that is going to happen on the concrete structural element. What will be the influence of these two on serviceability and durability of a concrete structure? Same like a temperature. What will be the effect of wear and erosion, okay, if concrete structure element is going to possess on serviceability and durability of a concrete structure? Okay. So, before going to this, let us define these terminologies. What is wear, or I can say what is erosion? Okay. A wear is defined as it is a wearing of a concrete surface by friction. A wear refers to, okay, removal of surface, a removal of surface or wearing away of the surface by friction. If two bodies are rubbed against each other, okay, then automatically a friction will be developed. Those friction will tend to develop the wear. Here I will tell you, that will be friction between the two bodies. Here one is concrete structural element and another, okay, another particle or some, okay, the whatever I can say the element, okay, those rubbing actions, okay, will create a wear. Okay. Next, what about erosion? Okay, it refers to wearing away of a surface. It refers to wearing away or removal of concrete surface by fluids or by liquids. Okay, a flow of liquids on the concrete surface is also dangerous. A flow of liquid on the concrete surface will also lead to the erosion. Have you understood? So, wear means wearing of a surface by friction, that is called wear. Okay, a removal of surface or wearing of surface by liquid or whatever the fluid, that is mainly by water, that will be called as erosion. So, this is the terminology. Okay, so now let us get into the mechanism, and this particular problem will be mainly come across in hydraulic structures. In hydraulic structures, floor slabs, rigid pavements. Okay, so these problems are commonly observed in this particular structure, majorly in hydraulic structures. Okay, so now coming to the mechanism of this, how exactly this process is going to happen and what is the extent of the damage. Okay, so this abrasion, what I can say, wear or whatever the abrasion or erosion I can say, okay, or both the wear and erosion, both the effect will be there. Okay, this abrasion erosion damage will be caused. Abrasion erosion damage will be caused, okay, by action of debris. By action of debris. Whatever the particles, okay, that will be left inside the water or any body, so that will tend to create a rubbing action. So those debris inside the water, okay, will tend to create a rubbing action. Okay, so that will create erosion damage, or what I can say, abrasion erosion damage. Okay, and also grinding against a concrete surface. Okay, so grinding against a concrete surface, and another one is by the action of debris. By both these actions, okay, this abrasion erosion damage that is going to happen. Okay, and as I stated, this particular erosion, wear and erosion is mainly seen on hydraulic structures. You can see, okay, the hydraulic structures components, the mainly affected parts are stilling basins, spillway. You can see, okay, the components of hydraulic structures have been showed in the photo or figure. You can see over there stilling basins, okay, apron, you can see the apron is of concrete, stilling basins, spillway, okay, all these components in the hydraulic structures will tend to get wear or erode. Okay, how exactly the mechanism that is going to happen? Okay, here the source of debris, okay, the source of debris, okay, that will be there, or I can say including the construction trash that will be left in the structure, construction trash, or what I can say debris. So those debris that will be tend to flow because of eddy current. You know what is eddy current? That is the development of a force. So because of the development of eddy current inside the whatever water, so those eddy current development will riprap or debris. Okay, those construction trash left will tend to create a erosion action or abrasion action, okay, in the concrete surface, will finally lead to the damages or cracks on the concrete structural element. Okay, so now how exactly this mechanism is going to happen? We can see from the mechanism, we can see from the photo, we can see clearly from the photo how exactly the mechanism of this is going to happen. You can see from the first figure, there will be uniform in the concrete, there will be no variations, okay. And from the second figure you can see, that means all the constants are stable. Aggregates, mortar, cement, everything is stable. You can see from the second figure, the aggregates is tending to get detached, or a mortar paste is coming out. Okay, so that is second figure. And the third figure you can see, okay, few more aggregates is trying to come out. Next, in the last figure, enormous aggregates or whatever the thing will be come out. Okay, so because of this riprap movement or debris inside the concrete structures, okay, so those things, okay, will try to create, okay, or remove these aggregates, okay, this riprap movement or construction trap, okay, that's water movement, will try to remove those aggregates, okay, or the cement paste or imbalancement, okay, all those things is going to happen. That you can see from the thing. So because of this removal of aggregates, okay, will lead to the reduction in paste bond strength. Okay, because of the bond strength between the aggregates and the cement paste is reduced, okay, obviously the aggregate will be detached outside, okay, and the cement paste will be loosened with deficiencies. Is it clear? So this is what the mechanism that is going to happen in the case of wear and erosion in the concrete. Next, how we can prevent this? How we can prevent this? We can prevent the effect of wear and erosion on concrete structure elements by proper hydraulic designs. Proper hydraulic designs. Okay, by proper designing of hydraulic structures, we can, that means a use of proper materials, what I can say. Okay, by designing all those things. Okay, we can overcome this. And the next is proper construction practice. Okay, proper construction practice. Next we can say use of steel fibers. Use of steel fiber, that is a very, very important part in the concrete. See, if you're going to use a fibers inside the concrete, you can arrest more amount of tensile stresses. If you use a steel fibers, or if you're going to use a fibers in the concrete, you can arrest a tensile stresses, or you can reduce a tensile stresses problem. Keep this in mind. Okay. Next, aggregate, whatever thing you are going to use should be of proper quality. Next, and very important thing, whatever the concrete we are going to use is of high compressive strength. If a compressive strength is higher, obviously we can resist a wear and erosion enormously. Automatically the reduction of wear and erosion can be done. Okay. So this is regarding effect due to wear and erosion on concrete structure, which will be having an influence on serviceability and durability. So with this, I am going to wind up today's session. Okay, we have been discussed effect due to temperature and effect due to wear and erosion. With these two things, I am going to end the session of today. We will continue in the next session with further effects. Thank you.